Good evening. Good evening to all of you.
Good evening, ma'am.
Good evening, Paulus. Been a long time. How are you,
Right,
Paulus?
I'm great. How are you, ma'am?
Nice to see you on Teachers' Day.
It's been 9 years, ma'am.
Yeah. Let's hope that we'll see your face also soon. Right now, you are not.
Yeah, sure. Definitely.
And you're speaking about perhaps one of the most uppermost thing. Top of the world, beyond the world, isn't it?
Yeah.
Okay, would like to know what you do. Okay, later on. Let's hope that we can talk a little afterwards. Okay.
Yeah, sure.
Where are you now? In India?
In India only, ma'am. Thrissur only.
So what? When did you do this course?
It's not a course. Like after my GCS, and I started working in institutions like JEE institutions and NEET coaching centers, and now I'm basically an entrance lecturer.
Okay, so you are in this. You are in the area of. Okay, but your MTech might be different, isn't it? Looks like your MTech
it's in power electronics.
Power electronics. Okay, yeah. Okay, it was your classmate, I believe, who talked about the clearance of the debris, etc. I think that is it. Yeah, you were the last batch wherein I attended all the seminars. I think
yes, that's right.
Yeah, so I think it was one amongst you who presented a theme of removing the debris from the skies.
In which year, ma'am?
Yeah, I think that could be your batch.
2012 only, right?
Yeah, it should be 2000. It should be your semester. Yeah. I'm not very sure, but I remember something like that. Of course, somebody did speak about. Okay, just a second.
Good evening, everyone. I hope I'm audible.
Yes, you are audible.
Okay, thank you, ma'am. Good evening, one and all. There is nothing bigger or older than the universe. These are the words of Stephen Hawking. Space is an inspirational concept that allows one to dream big. We are all gathered here for a talk on celestial mining by Mr. Paulos Thomas. Let's begin the function with a silent prayer. On behalf of Vidya Academy of Science and Technology, a hearty and warm welcome to each and every one of you gathered here. I also warmly welcome our proud alumni and speaker of the day, Mr. Paulos Thomas, to the session. I am sure everyone gathered here knows the importance of today. Yes, it's Teachers' Day. And today I came across an interesting and apt definition of a teacher. A multitasking educational rock star who lives to inspire and loves to encourage. Yes, true. Indeed, they are kind of a big deal. Feeling blessed to be a teacher, I now on this special day call upon our Dean Academics, Dr. Sudha Balagopalan, who is also a person I consider my teacher. We all would love to hear from you on this special day, ma'am.
Thank you, Akhila. Perhaps it's my time to speak. Okay, so what's happening right now at my end is one of my very former students has come over to my house to pay his respects along with the book. Okay, and incidentally, the book is what is called as Our Mathematical Universe. and another student of mine. Okay, very proudly I should say that Paulos is here to talk about again the universe. Okay, so what a coincidence. So this is what I wanted to share with you right away, because it happened just now. In fact, he's now standing outside and he has just delivered this book. In fact, he delivers a book on each of the Teachers' Day, and it's a great. Okay, I don't know what to say. It's a fulfilling moment. It's a moment when we feel that not the task, that the profession that we took on, or the role that we took on, does have its immense scope for making us fulfilled, as also in celestially happy. So let me borrow the same word. Okay, so meanwhile I also remember, of course I remember the batch of Paulos. I remember all of them. In fact, whatever perhaps some of the private interactions that we have, I suppose Paulos remembers just like I do. Okay, so there are quite a large number of, in fact, the students leave quite a lot of memories in our mind. And I always tell the students that you make us teachers. Okay, if you don't make us teachers, there's nothing that we can achieve. The respect that you give, the love that you give is ultimately multifold. Okay, in fact, it is multiplied. Okay, we give a drop and you give us an ocean, because everyone contributes. Okay, so I'm again remembering one of those earlier Teachers' Day, when a batch of course we were having classes then. We were having what are called as offline classes, contact classes. And at that time, it was September 5th again. So the students were not in a good mood to take lessons. So they said that we'll try to have, okay, in fact, I also went along with the idea. In fact, I also suggested that let's have a session or a class where no engineering teaching is being done, but let them share their experiences with their best of teachers. In fact, I got quite a large number of opinions, suggestions, and stories and anecdotes from the students. And ultimately, it was my turn. And when it was my turn, what I told them is what I'm going to repeat here. I told them that now I'm standing here in front of you, just like any teacher, and all of us teachers give you ideas, give you concepts, give you solutions, give you even problems, etc. And we slowly lead you on, and slowly you come towards us, you merge within us, and then you go forward. And then what we teachers do is to just turn back and have a look at you going ahead and conquering the world. And this is exactly what each one of you have done. In fact, I have many students listening to me, not just Paulos, but also some of the teachers who are handling classes here, and perhaps the innumerable number of messages that we all teachers are receiving today stands testimony to the fact that when we turn around, we see your conquering the world happening to be our paramount moment, the biggest moment of our life. So with much pleasure and happiness, I deliver this message to you that we are proudly waiting for each one of our students, okay, each one of us who come into our life to go ahead, conquer the world, and then remember that we are waiting here for you eternally. Even if the body is gone, the mind, the soul will always be there, waiting for you, waiting to see that you are conquering the world, you are a happy person, and you ultimately contribute to this universe of ours. Thank you for giving me a chance, and I suppose with that I'll close my mic. Thank you.
Thank you, ma'am, for those enlightening words. Now, before we begin our much awaited session, let me give you all a brief description about our speaker, Mr. Paulos Thomas. Mr. Paulos is the founder of SPT online classes from its inception in 2019 September. Formerly, he was lecturer in physics for 2 years in public school in Tamil Nadu, and also in various institutes like Ridgewan PSK, Malabar Classes, Spark Academy, Focus Academy, etc. He also worked as assistant system engineer at TCS. He graduated in electrical and electronics engineering from Vidya Academy of Science and Technology in 2012 and did his master's in power electronics and drives from Sahrodaya. He has also completed an online training by Stanford University on special relativity, and he holds membership in Astro Kerala and Society for Space Education Research and Development. To mention few of his accomplishments, Mr. Paulos received the Chancellor Vishwanathan Gold Medal for being the top outgoing student during his MTech. He has also won many awards for his presentations in national, state, and district level talks and competitions, and has completed 69 talks on various science and engineering topics all over India. And I believe this is the 70th talk that he's going to handle today. So it's indeed a proud moment for all of us involved to present our alumni, and I call upon my dear student, Paulos. Over to you, Paulos.
Thanks a lot, ma'am. Can you see me, ma'am? Am I visible?
Yes, sir. Yes, sir.
So, just a second. Okay. So, good evening, all. Being an alumni of Vidya Academy of Science and Technology, I'm very thankful to the principal and management for considering me as the resource person for the day. There are no words to express for the beautiful message given by one of my favorite teachers, Dr. Sudha Balagopalan. I normally tell to my friends that she is a walking encyclopedia of electrical engineering. I also cannot forget my beloved teachers, Dr. Mary P. Varghese, Mr. Sandumon sir, and Mrs. Agla Prashant ma'am, who helped me to coordinate with this right from the beginning. I extend my sincere thanks to all other teaching and non-teaching staff who worked behind this webinar and right from the beginning. I'm also very glad to see this participation come from in and around the country who are watching this program. Anyways, happy Teachers' Day to all my teachers. And I have one message I have to say is that the best teachers don't give you the answer, but they spark within you the desire to find the answer yourself. Okay, so I'm remembering all my teachers today who shaped me to become what I am now. And I'm very proud to say that I'm also a teacher now. And my sole passion is to spread science to many more people to come. Let's get into the celestial mind topic now. I'll share my video, ma'am. Just tell me whether you're able to see it or not.
Yes. Yes, it's visible. Yes.
Okay. So straight away, happy Teachers Day to all my teachers. Okay, so let us start our journey. Let us explore the universe and let us mind what all things that we have within our reach. Okay, so I'm starting from a very simple slide, which you all might be very aware with. We can see here a lot of planets. We can see moons, but something special that we are not very familiar with, you might be seeing here. You can see so many moons, right? Not just our moon. You can see the moons of many planets, other planets and all, right? And you can see a collection of, asteroids, or I can say, you can also see two belts separately, like asteroid belt and Kuiper belt. Also, you can see here, and there's some Trojans. Okay, you can see also some Trojans here. Okay, now let me tell you, in astronomy, okay, a Trojan is a small celestial body, okay, that shares the orbit of a larger one, remaining in a stable orbit. So that means Trojans, that might be a new word that we are here. Okay, it can share the orbits of large planets with large moons. It's a collection of rocky materials. Got it? Now, those are Trojans. Got it? Now, astronomy, the word, when I say it, it is a branch of science which deals with the celestial objects. Got it? It's not just celestial objects, but it deals with science and the physical universe as a whole. There is another branch called as cosmology, which is the science of the origin and development of the universe. There is another department called as astrology. I'm calling it as a department. It's not science. It's not scientific. That's why I'm not treating it as science. The study of the movements and relative positions of celestial bodies interpreted as having an influence on human affairs and the natural world. So this is the key thing that you have to understand from this first slide. Planets, moons, okay? Then you can see asteroid belt and Kuiper belt you can see, and then so many projects. Got it? Okay. Now, here you can see the comparison of some very familiar terms related to celestial objects, starting with comet. Okay, it's an icy body that releases gas. So it's basically ice. Got it? And there is a long tail for that comet. Got it? Then comes asteroid. That is the star of the talk. Okay, asteroid. I'll come to that later. But asteroid, the definition goes like that. It's a rocky body smaller than a planet. Okay, that orbits the sun. Is that clear? Then comes meteoroid. Okay, so here meteoroid is a rocky or metallic fragment of a comet or any other material. Meteor, that is basically the shower that we see during the nights in the night sky. It's a streak of light seen when a meteoroid heats up in the atmosphere. And meteorite, the meteor fragment that reaches the ground. That's what basically we get in the end. So these things are falling in one day itself. It's a lot of meteors are falling actually, but only few are hitting the ground. You might be knowing the reason. The savior is that atmosphere. So atmosphere is saving us from this meteorite impact. Because a lot of meteors, while entering itself, they will get burned out due to frictional force. Got it? So these are the key characters of today's talk. Here you can see a list of moons and dwarf planets. Okay? You can see the planet list and the number of moons for each planet. Starting with Mercury, Venus, they don't have any moons. Earth, yeah, but definitely we know what our moon is there. Mars has got 2. Okay, Jupiter 79, Saturn 82, it goes on. Till Neptune, they are considered as planets. Pluto was considered as a planet before, now it's considered as a dwarf planet. Got it? A dwarf planet. Now, in the brackets, you can see that the confirmed number of moons and some provisional moons. You can see that. So basically, a provisional moon means it's basically discovered. It's a discovered object which is in the orbit around the parent object. Okay, but these moons have not been named as of yet and are given just a temporary name just for identification purpose. Those are provisional moons. On the other side, dwarf planet, it's a celestial body that basically orbits the sun. So Pluto, we know that it's orbiting the sun, but it was taken out from the planet list, not because Pluto is no more a planet, because the planet definition is changed. So dwarf planet is basically a celestial body that orbits the sun, has enough mass to assume a nearly round shape, which has not cleared the neighborhood around its orbit, and it's not a moonose. Okay, it's not a moonose. So that is the list. In the list, you can also see after Pluto, you can see some other dwarf planets like Eris, Haumea, and Makemake, as well as Ceres. Okay, so it's not make, it's Makemake. Okay, fine. So that is the name of dwarf planet. Ceres is considered also as the largest asteroid. Is that clear? Here you can see the number of asteroids that we have detected, starting from very small sized asteroids like from 0.1 kilometer sized asteroid up to 900 kilometer sized asteroid. 900 kilometer one, definitely it is Ceres. 0.1 kilometer sized as asteroids. You can see nearly 2.5 crores asteroids we have detected. Means there are much more to detect. Basically, we believe that trillions or millions of asteroids are out there in the asteroid belt along with the Kuiper belt. Now, why I have put this table is because you can see here the 1 kilometer sized asteroids, okay, which are nearly 7.5 lakhs, 3 kilometer size are 2 lakhs, 5 kilometer 90,000, 10 kilometer 10,000 asteroids we have detected. Okay. Now, anything between 0.5 kilometer and 1 kilometer sized asteroid, if it is hitting the ground, I mean Earth's surface, it can literally whitewash, literally take a complete city out from the picture. If it is the size of 3 kilometer or something like 5 kilometer, between 3 and 5 kilometer, it can take a large continent. Anything more than that, something like 10 kilometer sized asteroid, if it is hitting the surface of the Earth, that is enough to completely, take all the species out from the world, which is definitely, we know one example, right? The asteroid hit 65 million years before Mexico, which is of the size of 10 kilometer, and it created a large crater called as Chicxulub crater. And even after that, so many asteroids have been hit. Okay, in 2013 Russia, there was an asteroid hit at Chelyabinsk. The size of that asteroid was only 19 meter, 19. Okay, so remember, 10 kilometer can literally take out the entire planet. Now, what is the frequency of this asteroid hits and all that we will see soon? But before that, we can see here the relative mass of these asteroids. Ceres is the biggest one, no doubt. It's the largest one. It's in the asteroid belt. That asteroid belt means the belt between planet Mars and planet Jupiter. Right? You can see all other asteroids according to their sizes. But the main attraction, you can see that bar diagram. It's a very interesting bar diagram. You know why?
ഇടയ്ക്ക് മലയാളത്തിൽ പറയാമോ, ബുദ്ധിമുട്ടില്ലെങ്കിൽ?
Ma'am, there are students from other states also.
You see them? Okay.
Yeah.
Okay. Once in a while, if you don't mind, I suppose Malayalam should be fine. I hope nobody will mind. Once in a while, okay?
Yeah, definitely. Okay. So back to the bar diagram. So in this bar diagram, what you can see is that, that red graph indicate the asteroid hit without any one. Okay. So the number of asteroids that have been hit on the surface of the Earth without any one. Look at that count. It's really, a staggering count, isn't it? What about that small yellow, graphs? Those are the asteroid hits just before 24 hours long. And that gray-scaled bar diagrams, okay, bar plot. Those are the asteroids that we have discovered up to 1 week in advance, and then they hit on the surface. So the key point is that it's extremely difficult to trace an asteroid. It's the key point. It's very difficult to trace an asteroid. Okay. So, ഒരു കാര്യം ഞാൻ മലയാളത്തിൽ ഞാൻ പറഞ്ഞ സ്ഥിതിക്ക് ഞാൻ പറയാൻ ആഗ്രഹിക്കാം. അതായത് ഇന്നല്ലെങ്കിൽ നാളെ നമ്മൾ എല്ലാവരും പ്രതീക്ഷിച്ചിരിക്കണം എന്ന് ഒരു ആസ്ട്രോയിഡ്. ഇറ്റ്സ് വെരി ഇമ്പോർട്ടൻറ്റ്. കാരണം our telescopes are not, they're not strong enough. നമ്മുടെ ടെലിസ്കോപ്സിനൊന്നും അത്ര ആസ്ട്രോയിഡ്സിനെ ട്രേസ് ചെയ്യാനുള്ള അത്ര കഴിവൊന്നും നമുക്ക് ഇപ്പോഴും കിട്ടിയിട്ടില്ല. The reason why it is difficult to see these asteroids? എന്തായിരിക്കും കാരണം? The reason is because these asteroids do not reflect light much. Light reflect ചെയ്യാനുള്ള കഴിവാണ്. Because it's very dark. Anything which is very dark, what we have learned, it absorbs the light, isn't it? That's the physics. അപ്പോൾ നമുക്കറിയാം ഏത് ബ്ലാക്ക് ഒബ്ജക്റ്റ് എടുത്തു കഴിഞ്ഞാലും അതിലോട്ട് ലൈറ്റ് അടിച്ചു കഴിഞ്ഞാൽ അത് റിഫ്ലക്ട് ചെയ്യുക, ലൈറ്റ് റിഫ്ലക്ട് ചെയ്യാന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ ഇറ്റ്സ് വെരി ഡിഫിക്കൽട്ട്, ബുദ്ധിമുട്ടാണ്. ലൈറ്റ് റിഫ്ലക്ട് ചെയ്യാൻ ബുദ്ധിമുട്ടാണ്. ഇറ്റ് അബ്സോർബ്സ്. അങ്ങനെ വരുന്ന ആസ്ട്രോയിഡുകൾ, ഓക്കെ, എസ്പെഷ്യലി ദോസ് ഹു ആർ ഹിറ്റിംഗ് നോർമലി ടു ദ സർഫസ് ഓഫ് ദി എർത്ത്, നോർമലായിട്ട് വരുന്ന ആസ്ട്രോയിഡുകൾ, ഇറ്റ് ക്യാൻ മേക്ക് എ ഗ്രേറ്റ് ഇമ്പാക്ട്. ഇറ്റ്സ് വെരി ഡേഞ്ചറസ്. എന്നാൽ ഒരു ആംഗിളിൽ വരുന്ന ആസ്ട്രോയിഡ്സ്, സം ആസ്ട്രോയിഡ്സ് കം ഇൻ ആൻ ആംഗിൾ, ഓക്കെ, സം ആസ്ട്രോയിഡ്സ് കം ഇൻ ആൻ ആംഗിൾ, and that there is more chance for, there is more probability for them to get burned out. Okay, so that's the problem. Anyways, the probability of, you know, a 10-kilometer sized asteroid to hit the nearby future, it's very less. കാരണം നമുക്ക് കാണാൻ പറ്റുന്ന ആസ്ട്രോയിഡ്സ് വളരെ ലാർജ് സൈസ് ആസ്ട്രോയിഡ്സ് മാത്രമാണ്. സ്മോൾ സൈസ് ആസ്ട്രോയിഡ്സ്, it's very difficult to spot it out. Is that clear? Now, how we name these asteroids? You know, it's very important that you should know also the naming part. It's very difficult to memorize all these things. Like, so there is a provisional designation method. Like, first we will put the year at which the asteroid was discovered, then an alphanumerical code, okay, in which the month at which that year is discovered, and the sequence of numbers. Once the orbit is confirmed, okay, നമ്മൾ ആ ഒരു ആസ്ട്രോയിഡ് കണ്ടുപിടിച്ചതിന് ശേഷം, ഓക്കെ, നമ്മളൊരു ആസ്ട്രോയിഡ്, ഓക്കെ, ഇന്ന സ്ഥലത്ത് ഒരു ആസ്ട്രോയിഡ് ഉണ്ട് എന്ന് കണ്ടുപിടിച്ച് കഴിഞ്ഞാൽ, then we will put another number, which is, you can see as an example, 433. Along with that, those who have discovered that ആ ആസ്ട്രോയിഡ് കണ്ടുപിടിച്ചത് ആരാണ്, he will be suggesting some name, and here you can see Eros, and that number will be in a parenthesis. Okay? That is how we name the asteroid. Just for information purposes. Now, you can see here the number of asteroids literally, you know, floating in the space. And this is a simulation of the tracked asteroids. നമ്മൾ ഇതുവരെ ട്രാക്ക് ചെയ്തിട്ടുള്ള, അല്ലെങ്കിൽ ട്രേസ് ചെയ്തിട്ടുള്ള ആസ്ട്രോയിഡ്സിന്റെ ഒരു സിമുലേഷൻ. It's like dust particles literally everywhere. You can see the sun at the middle, then followed by Mercury, Venus, Earth, Mars. You can see those orbits are the orbits of the planets. And we are basically, it's like it's a swarm of asteroids. Three asteroids നമുക്ക് ചുറ്റും. ഇപ്പൊ നമ്മൾ ഇതിനെ പറ്റി worry ചെയ്യണോ എന്നുള്ള ഒരു question ഉണ്ട്. At the same time, we have to also think that whether we can bring it into something good. ഇതിനെ നമുക്ക് യൂട്ടിലൈസ് ചെയ്യാൻ പറ്റുമോ? Fine. So to the next slide. Bolide events. Bolide. It's a French word. And this picture, you can see that the asteroid hits on the surface of the Earth during the period 1994 to 2030. കുറച്ചൊന്നുമല്ല, സർവര കുറേ വീണിട്ടുണ്ട്. During the daytime, during the nighttime. നമുക്ക് പ്രതീക്ഷിച്ചിരിക്കാൻ പറ്റാത്ത സമയത്ത് ഒരു ആസ്ട്രോയിഡ് ഹിറ്റ് വന്നു കഴിഞ്ഞാൽ എന്ത് ചെയ്യുമെന്നുള്ള ഒരു ക്വസ്റ്റ്യൻ പോലും വളരെ ഇമ്പോർട്ടൻ്റ് ആണ്. Like, even if you get a warning, like a week before it's going to help or not, and the research says no, it's not going to help. Like, even if you get an information, like suppose that the asteroid is going to hit on Kerala, just imagine, ആണെങ്കിൽ ഒരു ആഴ്ച മുമ്പ് നമുക്ക് ഇൻഫോർമേഷൻ കിട്ടാം from ISRO. What will we do? We basically, the main thing is to evacuate, right? നമുക്ക് സ്ഥലം വിട്ട് പോവുക എന്നുള്ളത് മാത്രമാണ് നമ്മുടെ മനസ്സിൽ ചിന്തകൾ. After all, the life is more important, right? But the problem is, ആ സമയത്തായിരിക്കും full, you know, the entire streets will be in a rush to get into other places, to get into aircrafts, completely blocked out. So the research even says that there is no point in evacuating. All highways are completely blocked out in a situation. So even, you know, with 1 week warning polling is helpful in the reality. And you can see that dots of different sizes, okay? And those sizes, large size means, large size dot means it's having more energy during the impact. ഇതാണ് boliter events. Boliter means fireball. It's like a fireball. So when you see it right there on the night sky, and if you see a meteor, it's like, you can say it as a boliter. It's like fireball coming. It's a large impactor. അങ്ങനെയൊക്കെ നമുക്ക് bolete എന്ന ടേമിനെ നമുക്ക് പറയാം. And see this. You can either, it's not a horror movie or anything like that, but you can see that different sized asteroids and the frequency of it. So by seeing this, you will be happy, I believe. Why? Because an asteroid of size 10 kilometer, the frequency of that to come is nearly 100 million years. 100 million വർഷം എടുത്താൽ മാത്രമേ അത്തരം ഒരു ആസ്ട്രോയിഡ് വന്ന് ഹിറ്റ് ചെയ്യാനുള്ള പ്രോബിലിറ്റി. And you can see that other numbers also. 25 meter sized asteroid, 200 years വരുമ്പോഴാണ് അതിന്റെ ഇമ്പാക്ട്. അപ്പൊ ഇത് കാണുമ്പോൾ നമ്മൾ വിചാരിക്കും ഓക്കെ ഫൈൻ, 200 വർഷം കഴിഞ്ഞ് പ്രതീക്ഷിച്ചാൽ മതി. അങ്ങനെയാണോ? അങ്ങനെയല്ല. That's not the way to understand this picture. It's been 65 million years that an asteroid size of 10 kilometer has been hit. Means we are basically in the century where there can be a chance for a hit of 10 kilometer size asteroid. But since അത്രയും സൈസിലുള്ള ആസ്ട്രോയിഡ്സിനെ കണ്ടുപിടിക്കാനുള്ള ടെലിസ്കോപ്സ് നമുക്കുള്ളത്, space telescopes we do have. Hubble is there now. James Webb is going to be launched. So ഒരു തരത്തിൽ പറഞ്ഞു കഴിഞ്ഞാൽ for at least next 200 years, I can say we are in a safe zone of 10 kilometer or 5 to 10 kilometer size or more than that size asteroids impact. But what about asteroids which are less than 1 kilometer? Those are the actual villains. You know why? Because we cannot see them. That's the problem. What will happen, when these asteroids hit the surface of the Earth? Can completely block the sunlight. Number one, a lot of dust will, arise from the surface of the Earth. Tsunamis, global cooling. It's like a mini ice age. As well as the crop failure can happen. Big thing is that there can be chance for a war also, and that's a very interesting thing. Adeങ്ങനെയാണ് സംഭവിക്കുക? Chance for the war will happen is like when suppose an asteroid size of say 25 meter is hitting on the surface of the Earth. Fine, and imagine it completely whitewashed a city or a country, a European country. എല്ലാ തവണയും കേരളത്തിൽ ആസ്ട്രോയിഡ് വീഴുന്നു പേടിക്കുന്നത്. ഇതൊരു യൂറോപ്യൻ കൺട്രി, അവിടെ പോയി വീഴട്ടോ. അങ്ങനെ വീണ് കഴിഞ്ഞാൽ what will happen? There is a large chance for other countries looking for the resources. അവിടെ എന്തായാലും പോകാനുള്ളവർ പോയി കഴിഞ്ഞാൽ അവിടുത്തെ റിസോഴ്സസ് എല്ലാം എടുക്കാനായിട്ട് ബാക്കിയുള്ള കൺട്രീസ് നോട്ടം ഇട്ട് നിൽക്കും. This is the chance for war. So these are the situations. So these are the things that will happen. And even global famine. അത് വരെ സംഭവിക്കാം. അത് നമുക്ക് അറിയാവുന്ന കാര്യം. But war was the question, like whether that can happen. Understand? So these are the things that will happen. Now, the question is why we should mine an asteroid, or whether we should mine moons or something else. It's a big question, right? What is the attraction of asteroids? And don't know asteroids focus it. Let's see a comparable study, and here you can see on the left side, you can see the moon. Moon is basically 384,000 kilometers away from the Earth. Okay, and it's in a feasible gravity well. Okay, that's fine. We have a lot of natural resources there, like helium-3, water, silicon, rare earth metals, and it's good for deep space missions. അവിടെ നിന്ന് ലോഞ്ച് ചെയ്യുന്നതാണ്. എർത്തിൽ നിന്ന് ലോഞ്ച് ചെയ്യുന്നതിനേക്കാളും ഏറ്റവും those are the advantages of moon. And when it comes to asteroid, very accessible. Opposite thing is that don't think that asteroids are very far away and moon is the closest one. It's not like that. There are many asteroids, maybe 1,500 to 3,000 asteroids we have actually nearer to Earth than the moon. ഇതൊന്നും നമ്മൾ ഒരു സോളാർ സിസ്റ്റത്തിന്റെ ഒരു പിക്ചർ കാണുമ്പോൾ നമ്മൾ ശ്രദ്ധിക്കണം, അതിലൊന്നും ഇൻക്ലൂഡ് ചെയ്യില്ല. അത് ഇൻക്ലൂഡ് ചെയ്ത് കഴിഞ്ഞാൽ പിന്നെ പ്ലാനറ്റ്സിനെ കാണില്ല. അതാണ്. Now, Another advantage is that you need only very less fuel. The thing is, the reason is because of low gravity. Asteroids in the pressure, if you stand on the asteroid, okay, just imagine, and then you just jump, what will happen? There can be a chance for you to be part of space and you might not come back. You might have crossed the escape velocity. This is the problem. Asteroid അങ്ങനെ ഒരു പ്രോബ്ലം ഉണ്ട്. നമ്മളൊരു സ്പേസ് ടൂർ ഒരു ആസ്ട്രോയിഡിലോട്ട് പോവാം എന്നൊക്കെ വിചാരിച്ച് പോയി കഴിഞ്ഞാൽ അവിടെ നിന്നിട്ട് ആസ്ട്രോയിഡിന്റെ കണ്ട സന്തോഷത്തിൽ ഒരിടത്തൊരു ചാട്ടം ചാടി കഴിഞ്ഞാൽ പിന്നെ രക്ഷിക്കാൻ ആരും വരണമെന്നില്ല. അപ്പൊ ആസ്ട്രോയിഡ് അങ്ങനെ ഒരു പ്രോബ്ലം ഉണ്ട്. മൂണിൽ അതില്ല. കാരണം basically you can come back to the surface of the moon. The gravity is 0.6 the gravity of the earth. Understand? In the case of asteroid, there are a lot of rich range of resources: water, methane, rare metals, platinum, gold. ഇതെല്ലാം asteroids. ഇതാണ് നമ്മുടെ ഒരു നമ്മൾ നോക്കുന്നത്. These rare earth metals. അതാണ് നമ്മൾ basically concentrate. കാരണം asteroids are basically the part of the core of the failed planets. You know why? Because ഒരു പ്ലാനറ്റായി മാറാൻ സാധിക്കാതെ പോയിട്ടുള്ള ഒരു കോറിന്റെ റിമെയിൻസ് ആണ് ഈ ആസ്ട്രോയിഡ് പീസസ് എന്ന് പറയുന്നത്. സോ ഈവൻ ഓൺ ദ സർഫസ് ഓഫ് ദി എർത്ത് നമുക്ക് കിട്ടാവുന്ന rare earth metals in the quantity is very less. Its density is much more. So basically all the denser elements will go towards the core, and that's why it's very difficult to mine. And the gold and platinum ഭൂമിയിൽ ഇല്ലാതിരുന്നിട്ടല്ല നമ്മൾ ആസ്ട്രോയിഡ്സ് തപ്പിപ്പോകും. It's very difficult to reach the center of the earth. You know how it's 6,400 kilometers, the radius of the earth. And so far we have gone up to 16 kilometers. Say 16 and 20 kilometers anengil polu, it's like scraping with a blade on the surface of an apple. Athra maatrame nammal poyitullu. It's very difficult. Adu polum poyittunde ennu parayunnu, it's by drilling, and after that the drilling machine itself got jammed after going that much distance. It's very difficult. It's because of the extreme pressure, extreme temperature after that layers. So it's very difficult to mine on the surface of the earth. And that's why the asteroids are coming into the picture. Extreme importance in asteroids in the reason. And there are other, you can see the perpetual sunlight. The perpetual sunlight will be there. That means all the asteroids not necessary to orbit around in its own axis. Some may tumble. Okay, കാരണം ഇതിന് ഒരു സ്പെഷ്യൽ ആയിട്ടുള്ള ഓർബിറ്റ്, അതിന് തന്നെയുള്ള ഒരു ഓർബിറ്റ് ഉണ്ടാവും. Like the earth is rotating in its own orbit. There is no chance for that. Asteroids എല്ലാ asteroids പല type. Okay. Fine. And here you can see what are things you can basically extract from an asteroid. Just an example, if you take a single 500 meter sized water rich asteroid, you can an estimated amount of $5 trillion equivalent. What are things you get from a water rich asteroid? You can get rocket fuel. If you get water, you can split into hydrogen and oxygen, and you can use it as a rocket fuel. Breathable air, drinkable water. ഇതൊക്കെയാണ് first priority, rather than getting into rare earth metals, because it's very difficult to take the entire fuel with the rocket and go to there and mine and come back. അതിനുള്ള fuel നമ്മുടെ റോക്കറ്റിൽ ഉണ്ടാവില്ല. Why? Because a rocket means the 90% of that rocket will be filled with fuel, and remain that 10%. Okay, fine. At 10% മാത്രമാണ് whatever thing we have to take into the space. Now, the entire remaining 90% of the weight of the rocket is fuel, liquid hydrogen, liquid kerosene, liquid oxygen, goes on like that. This is the problem. So, ഇത്രയും fuel ആയിട്ട് അവിടെ പോയി മൈൻ ചെയ്ത് തിരിച്ചു വരാൻ വരെ അത്രയും വലിയ റോക്കറ്റ് manufacture. It's very difficult. So why can't we just go there, okay, and mine the fuel so that whenever we need fuel, we are basically mining it, right? So other നമുക്ക് use ചെയ്തു. അതാണ് അതിന്റെ ഫസ്റ്റ് പ്രയോറിറ്റി നമ്മൾ water rich asteroids ആണ് കൊടുക്കുക. And if once we are ready for mining the other asteroids, you can go for the other type of asteroids, which I will classify later, but you can see here, 500-meter platinum rich asteroid. It's worth, you can see that $2.9 trillion US dollars. The platinum rich asteroids, you can see that it can reduce the cost of the electronics, it can electrify transportation, and it can make the earth green. Why and how? Because we can reduce the mining on the surface of the earth, right? We can focus on asteroids. Hope we got that. Now, these are some elements that you can see which are enriched on asteroids, like, including iron, cobalt, nickel, rhodium, palladium, osmium, iridium, those are. We can see that catalytic converters, LCDs, advanced materials, cancer treatments, all these, if you are getting all these elements. So you can see that it's 196 times more platinum is there on the surface on the surface of asteroid, like comparing with the surface of the earth. For asteroid mine ചെയ്തു കഴിഞ്ഞാൽ ഇത്രയും platinum കിട്ടാണെങ്കിൽ, right, ഇത്രയും other rare earth elements കിട്ടാണെങ്കിൽ, you can, it's not about being rich, it's about satisfying the basic needs of the entire humanity. And here we can see the asteroid composition, which all elements are there in each asteroid. The first one is Ryugu, which is of $83 billion. Estimated value on Ryugu. It's actually Ryugu. Then you can see others asteroids and their composition. And the highlight is the last one. It's actually 16 Psyche. Okay, you can get nickel, iron, cobalt, gold. The Psyche asteroid is actually within our reach. That's the main attraction. Okay, it's actually within our reach. We can go there and mine once we are ready for it, and it's having a comparable orbit with the orbit of the Earth. അതുകൊണ്ട് വലിയ പ്രശ്നങ്ങളില്ലാതെ അവിടെ പോയി നമുക്ക് മൈൻ ചെയ്യാനായിട്ട് പറ്റിയിട്ടുള്ള പല ആസ്ട്രോയിഡ്സിനെയും നമ്മൾ നോക്കി വെച്ചിട്ടുള്ളതിന് ഒരു നല്ലൊരു പ്രയോറിറ്റി, ഹൈ ചാൻസ് നമ്മൾ സൈക്കിക്കാണ് കൊടുക്കുക. സൈക്കിക് $27.67 billion worth. Now you can see here some crude sample return missions. Okay, starting from Apollo 11 mission up to Apollo 17 missions. I hope you know that. Now don't say that no one has gone to the moon. We have gone to the moon. Okay, in which Apollo 13 only was a failure. Got it? And nearly 382 kilogram lunar soil has been brought to Earth. Not only that, Russia, Japan, they all have made their crude sample return missions, and Russia have basically collected particles from the low Earth orbit, and Japan also have collected particles from the low Earth orbit. But it was NASA that has the only, or the USA is the only country that have made their crude sample return mission, and they are the only country that have gone to, crude mission. Now, when you see a robotic sample return missions, our Soviet Union high priority. They have their lunar missions. They have collected samples. Look at the year. That's the highlight. 1970. Okay. Space war. Space war 1950s to 1970s. First between US and Soviet Union. It's like a Cold War, right? And they have collected samples. Okay. Once after 1972 and all, they lost the interest. We got all the enough moon samples we got, and NASA has distributed to all the countries, including India, for research activities. Lunar soil, lunar regolith. And after that, മൂണിലോട്ടുള്ള attraction കഴിഞ്ഞപ്പോൾ, NASA has planned to go to asteroids. And yes, there are sample return missions have been conducted on asteroid source. You can see that Japan has done it with their famous Hayabusa missions, Hayabusa 1 and 2. And also NASA has taken their rover to asteroid Bennu with their OSIRIS-REx mission. That's NASA's last mission, OSIRIS-REx. It's basically in transit. It will reach in 2023. It's a return journey. China also has done that. People are focusing on the asteroids. You can see here some pictures of Neil Armstrong, on the surface of the moon. And there is always a question that students used to ask me, like, why, sir, there are no stars on the background of the picture? Like, space moon surface a photo stars are. Isn't that staged? Students, let me answer that question in very simple words. Like, photo it's a very bright objects are reflective. Stars in the light very fade on. Kodak camera uses that photo to use the Kodak camera. And very bright objects in light to reflect with a camera. So it won't pick up the fade lights from stars. This is the reason. It's not staged. Don't believe that. On the other side, you can see the Perseverance landing animation, okay, by NASA. The Perseverance is very famous mission where there was a small helicopter inside that, which you can see in the below picture, that Ingenuity helicopter. Perseverance is the key mission to collect samples from Mars, and whether there is life on Mars before the Perseverance mission. And what it does is that once it collects the sample, you can see here, sample collected here, you can see the sample tubes in small boxes. People keep these small tubes filled with sample, Martian soil, okay? And then it waits for the NASA to launch another return lander, okay, which is Mars sample return lander. Waiting. Then Perseverance will come to this Mars sample return lander, and it will hand over. Okay, it will hand over the collected samples. Then what it does, that lander will launch its collected sample to the Martian orbit. From there, it will be collected to the Earth. Like, how complicated all these things are. And even, yeah, definitely India also will come into the picture. Like, because after all, our country has taken a probe to the orbit of the Mars for the very first time. Very first time means the first attempt. India possible, so you have to believe in yourself. That's the key point. You can see some pictures here of the Genesis rock, which has been brought back from Apollo 15 mission. In 1971, you can see a meteorite, which is from asteroid Vesta, that fell on Africa. And you can see here another meteorite, which has been believed like from ancient Mars. And you can see the OSIRIS-REx mission. Then the video, legs camera pick India, Earth load footage OSIRIS-REx mission, collecting the sample from asteroid Bennu. Okay, fine. Now, as I already said, there is no point in taking the entire fuel to space and then do the mining. Instead, what we can do, we can collect the samples. Okay, we can collect the sample from the Earth. Sample collect. Sample means, basically mine the water extract the fuel use. We should understand one thing, that it is $20,000 it will take to take 1 liter water. നമ്മൾ കടയിൽ പോയി വാങ്ങുന്ന 1 ലിറ്റർ വെള്ളത്തിന്റെ കുപ്പി സ്പേസിലോട്ട് എത്തിക്കാൻ ഇപ്പോൾ $20,000. അത് വെള്ളത്തിന്റെ റേറ്റ് അല്ല, അത് ആ റോക്കറ്റ് ഉണ്ടാക്കി അവിടെ എത്തിക്കാൻ വേണമെങ്കിൽ ഇത്രയും എമൗണ്ട് വേണം, 1 ലിറ്റർ വെള്ളം സ്പേസിലോട്ട് എത്തിക്കാൻ. സോ നമ്മളിവിടെ വെള്ളം പാഴാക്കും, ശരിയാണ്. വെള്ളത്തിന്റെ വില പോലും അറിയാത്ത വെള്ളം നമ്മൾ പാഴാക്കുമ്പോൾ സ്പേസ് നമുക്ക് അതിന് അത്രയും ഇമ്പോർട്ടൻ്റ് ആണ് വെള്ളം എന്ന് പറയുന്നത്. ഈവൺ ഇൻ ഇന്റർനാഷണൽ സ്പേസ് സ്റ്റേഷൻ ആസ്ട്രോണറ്റ്സിന്റെ സ്വെറ്റ് അത് പോലും വീണ്ടും റീയൂസ് ചെയ്ത് കുടിക്കുന്ന ഡ്രിങ്കബിൾ വാട്ടർ ആക്കി മാറ്റുന്നു. അത്രയും ഇമ്പോർട്ടൻ്റ് ആണ് H2O. Now, classification of asteroids. First one, C-type asteroids. C-type asteroids are ഏറ്റവും കൂടുതൽ you can see and it's high abundance of water on the asteroid belt. ക്ലാസിഫിക്കേഷൻ എന്ന് പറയുമ്പോൾ ABCDEFG ഇങ്ങനെ പോകുന്നുണ്ട്. അതിൽ 3 ക്ലാസിഫിക്കേഷൻ മാത്രമാണ് ഏറ്റവും ഇമ്പോർട്ടൻ്റ് ആയിട്ട് ആസ്ട്രോയിഡ് ബെൽറ്റ്. ആസ്ട്രോയിഡ് ബെൽറ്റ് മീൻസ് again to remind you between Mars and Jupiter. And these C-type asteroids are the most common asteroids. ഇതാണ് ഏറ്റവും കോമൺ ആയിട്ട് നമുക്ക് കാണാൻ പറ്റുന്ന ഒരു 70 to 80% നമുക്ക് C-type carbonaceous. അതാണ് C stands for carbonaceous. What do we get from that if you mind? നമ്മൾ അതിൽ C-type മെയിൻ ആയിട്ട് ഫോക്കസ് ചെയ്യുന്ന എന്താണ്? വാട്ടർ, വെള്ളം കിട്ടാനാണ് പോകുന്നത്. അപ്പൊ ഇവിടെ നിന്ന് വെള്ളം എടുത്ത് അങ്ങോട്ട് കൊണ്ടുപോയാൽ പോരെ എന്ന ചോദ്യത്തിനുള്ള ഉത്തരമാണ് മുമ്പ് പറഞ്ഞത്. It's very costly. Okay, so it also contains organic carbon, phosphorus, and other key ingredients for fertilizers. As I said, it's very, very dark. Then comes S-type asteroids, stony, silicaceous type asteroids. What's attractive? What's attractive? And a lot of metals are there on the surface of these type of asteroids. And ഒരു 10 meter size ഉള്ള ഒരു ആസ്ട്രോയിഡ്, അത്തരം ഒരു ആസ്ട്രോയിഡ് നമ്മുടെ കയ്യിൽ കിട്ടിക്കഴിഞ്ഞാൽ ഇറ്റ്സ് ബേസിക്കലി 650,000 kilogram ഓഫ് മെറ്റൽ അതിൽ നിന്ന് നമുക്ക് എക്സ്ട്രാക്ട് ചെയ്യുകയും 50 kilogram ഓഫ് പ്ലാറ്റിനം ആൻഡ് ഗോൾഡ് കിട്ടും. So those are S-type asteroids. ഇതാണ് നമ്മുടെ കഥയിലെ M-type asteroids, metallic asteroids, 16 site. അതാണ് നിങ്ങളിപ്പോൾ കാണുന്നത്. On the one side it is the artist concept, on the left side is the photo actually we have taken. നമ്മൾ എടുത്തിട്ടുള്ള ഫോട്ടോ ലെഫ്റ്റ് സൈഡിലുള്ള ഫോട്ടോ, റൈറ്റ് സൈഡിലുള്ള ഫോട്ടോ ഒരു കോൺസെപ്ഷൻ ആയിട്ട് വരച്ച് വെച്ചിട്ടുള്ള M-type asteroid, which is very, it contains a lot of gold and other very important rare earth metals. It's basically the core of a planet. A failed planet നമ്മൾ വിളിക്കുന്നത് അത്. ഇതൊരു പ്ലാനറ്റായി മാറേണ്ടതായിരുന്നു. Okay. Now, what you can see here is that how we, classification കഴിഞ്ഞാൽ we need to go there, right? We need to go there and we need to identify which asteroid is the best one. So what we do, we launch rockets, we deploy satellites. These satellites will go to the asteroid belt, will examine them, and then they will launch small probes to these asteroids. These probes will collect the information. It will redirect the information to satellite. Satellite will redirect the information to Earth. And then information, whether it is a water-rich asteroid or not, how much water it might contain in that, തുടങ്ങിയിട്ടുള്ള വളരെ ഇമ്പോർട്ടൻ്റ് ആയിട്ടുള്ള ഇൻഫോർമേഷൻ ആണ് ഇത് പാസ് ചെയ്യുന്നത്. നമുക്ക് അതിൻ്റെ ഒരു സ്മോൾ വീഡിയോ നമുക്ക് പെട്ടെന്ന് കണ്ടു. ഓക്കെ, video is actually done by Planetary Resources. Planetary Resources എന്ന് പറയുന്ന കമ്പനിയാണ് ഇപ്പോൾ ആസ്ട്രോയിഡ് മൈനിങ്ങിലെ ഏറ്റവും മുൻപന്തിയിൽ. ഓക്കെ, സോ ജസ്റ്റ് ടു കൺഫേം ദാറ്റ്. അഖില മാം, ആ വീഡിയോന്റെ സൗണ്ട് കേട്ടിരുന്നു?
കേട്ടിരുന്നു കേട്ടോ, കേട്ടിരുന്നു.
താങ്ക് യു. ഓക്കെ, സോ next is how we are going to mine this. Okay, we spotted out the asteroids. Then namukadu mine cheyyam. Some small techniques. The first one is surface mining. It's like, you know, the JCB grabs the soil. അതുപോലെ തന്നെയുള്ള വളരെ സിമ്പിൾ ടെക്നിക്സ് ആണ് നമ്മൾ ഇവിടെ യൂസ് ചെയ്യുന്നത്. We don't need to apply complicated methods. കാരണം it's very difficult to reach there itself in the first place, right? And you know, it can collect rubble piles, okay, potentially making this approach. It's very difficult also. It's simple and the partner code. When you grab this, okay, when you grab this using this jaw-based object, rubble piles are it's like loose grains. Okay, then the second method is shaft mining. Shaft mining, you know, there will be a long shaft. Okay? Long shaft will be coming out from small satellite-like system, and from there it will basically mine the surface of the asteroid and it will collect the samples. Okay, it will collect the samples. The problem of this kind of shaft mining is that, number one, we need precise knowledge where exactly to dig. That's the problem. ഇവിടെയെല്ലാമാണ്, you know, the future engineers നമുക്ക് വേണ്ടത്. എവിടെയാണ് എക്സാക്ട്ലി ഇത് കൊണ്ടുപോയി ഡിഗ് ചെയ്ത് നമുക്ക് ഏറ്റവും നല്ല സാമ്പിൾ കിട്ടുന്നത് എന്നുള്ള കൃത്യമായിട്ടുള്ള അറിവ് വേണം. And then the sample ചെയ്ത് കളക്ട് ചെയ്ത് എടുത്താൽ മതിയോ? ഇല്ല. It has to be taken back to the earth. So we need transportation systems for that. ഇതാണ് ഷാഫ്റ്റ് മൈനിങ്ങിന്റെ ഒരു പ്രോബ്ലം. മാഗ്നറ്റിക് റേറ്റ്സ് ഈസ് കുറച്ചുകൂടി സിമ്പിൾ ആയിട്ടുള്ള ഒരു ടെക്നിക്കാണ്. ബേസിക്കലി ടെമ്പററി ഓർ പെർമനന്റ് മാഗ്നറ്റ്സ് ഉപയോഗിച്ച് മെറ്റാലിക് ആസ്ട്രോയിഡ്സിന് മുകളിൽ 2 റൗണ്ട് അടിച്ചു കഴിഞ്ഞാൽ it can basically collect the magnetic core. It can basically attract the magnetic core at least. ഇതാണ് മാഗ്നറ്റിക് റേറ്റ്സ് കൊണ്ടുള്ള ഒരു യൂസ്. പക്ഷെ ഇതിൽ നിന്നെല്ലാം വ്യത്യസ്തമായിട്ടുള്ള ഏറ്റവും the best method of mining is none other than optical mining. ഇവനാണ് the best method എന്ന് എനിക്ക് പറയാം. What it does is that it focuses the solar light. Okay, it makes some sense. The water-rich asteroids വേണ്ടിയിട്ടാണ് നമ്മൾ യൂസ് ചെയ്യുന്നത്, like carbonaceous asteroids. That's the first priority. It basically focuses the sunlight. Okay, what will happen? With 510 degrees Celsius taken, it will start to release these hydroxyl compounds, water vapor. This water vapor can be collected in small, you know, containers, and then it can be taken. It can be used as the fuel for that rocket system. Vellam, water, it's very important. As I already said, it can basically split into hydrogen and oxygen. Hydrogen, you can use it as the best fuel. Oxygen helps for combustion, right? So water-rich asteroids extract ചെയ്യുന്ന mechanism on optical mining. Okay. Now you can also do that on dead comets and other nearby celestial objects. Another process is MON process, which is a chemical process. It's a chemical process. Basically, what it does is that it passes the carbon monoxide gas and 50 to 60 degrees Celsius temperature undertaken. It will, you know, it will release the nickel tetracarbonyl and iron pentacarbonyl gases along releasing. Other than the temperature apply to the, we can extract the nickel and iron, and what the residue is basically platinum and gold. MON process. Okay. Now, they are also enclosed in materials that are resistant to corrosive carbons, because basically the gases that are coming are corrosive tetracarbonyl gases. Got it? That's MON process. Now, self-replicating machine. The people, you know, the students who are basically planning to join the computer science, engineering, artificial intelligence, avarkellam ulla 3D printing, mechanical engineering, avarkulla oru challenge aanu, you know, this company, Advanced Automation for Space Mission, what they're planning to do, you know, it's very interesting that they make robots. Okay, they make robots not like the conventional method by making robots from the surface of the earth and sending to the. Instead, this robot makes the copies of themselves on the surface of the moon. 80% robots are there. Adinte copy thanne undakum. റിമൈനിങ് 20% മാത്രമേ എർത്തിൽ നിന്ന് നമുക്ക് മെറ്റീരിയൽ അങ്ങോട്ട് കൊണ്ടുപോകേണ്ട ആവശ്യമുള്ളൂ. ബിക്കോസ് ആഫ്റ്റർ ഓൾ lunar soil is very good for constructing base camps. This is a result that we got from the researchers. So, after all, lunar soil കിട്ടിയിട്ടുണ്ട്, അതിൽ ഇഷ്ടം പോലെ സയന്റിഫിക് സ്റ്റഡീസ് നടത്തിയിട്ടുണ്ട്. From that you can use it as instead of cement. Cementന്റെ പകരം നമുക്ക് lunar regolith നമുക്ക് യൂസ് ചെയ്യാം എന്ന് നമുക്ക് മനസ്സിലാക്കി. And ഈ ചെയ്തുകൊണ്ടിരിക്കുന്ന, you can see in the picture, it's done by relativity space. Relativity space ന്റെ ഒരു ഈ അടുത്താണ് ഞാൻ അറിഞ്ഞത് relativity space എന്നുള്ള ഒരു കമ്പനിയും അവരുടെ ഇന്നോവേഷൻസ്. I was shell shocked to see that their innovation includes 3D printed rockets, and they are going to launch the next year the first version, which is Terran 1, and in 2024 they are going to launch Terran R. അതിന്റെ ഒരു ചെറിയൊരു ക്ലിപ്പ് നമുക്ക് നോക്കാം. Okay. So that's by relativity space. Relativity space and it's very attractive, right? So then comes Kepler Energy and Space Engineering. This is another company. What their plan is, is to send 4 module automated mining system and to collect the asteroid in like 10 to 40 tons of asteroid. They can bring it back to surface of the Earth. Are using another the basic the technology from the successful missions like the Rosetta mission. I hope you know that we have also landed on. We means I consider it as the entire Earth people. Okay, so we have landed on a comet in the Rosetta mission. Okay, and also Japan's famous Hayabusa mission. Other than the technologies of Padichetta, they are planning to take their systems to asteroids, okay, and to collect 40 tons and bring it back to low Earth orbit. And most of these companies, what their plan is to bring the asteroid towards the low Earth orbit, and there they are planning to mine it out. Got it? And Deep Space Industries, along with NASA, അവരുടെ ഏറ്റവും ഫേമസ് ആയിട്ടുള്ള ഒരു 3-stage mission, starting from Fireflies, Dragonflies, and Harvesters. Fireflies, what it does is that it will go basically there and examine. Okay? Just go there and examine. And we'll understand, okay, these asteroids are the ones which is best for mining. Dragonflies can basically collect 5 to 10 kilogram, and they can bring it to the low Earth orbit, and there they can mine, or even to the surface of the Earth. Harvesters are what we can say the big B. You can see that it basically collects huge lumps of asteroid. It can basically collect a huge lumps of asteroid, and it can bring it to the orbit. But the TransAstra, the company, ഇതായിരുന്നു ഞാൻ research ചെയ്തപ്പോൾ എന്നെ ശരിക്കും attraction തോന്നിയിട്ടുള്ള company, TransAstra. Okay, so those who are planning to switch to astronomy, astrophysics, and all, ഈ ഒരു company ഒന്ന് നോട്ട് ചെയ്ത് വെക്കാം. They have a huge innovation list in their website. You can search that, okay, and it contains asteroid miners, optical mining, space propulsion, omnivore thruster, and so on. And എല്ലാം വായിച്ച് നിങ്ങളെ ബോറടിപ്പിക്കുന്നില്ല. But അതിലെ highlight asteroid miners are. Just we can see the picture of it. അതും ഒരു 3-staged asteroid miner. Okay, the first one is the TransAstra Mini B asteroid miner. Basically takes small asteroids, and then it will do the optical mining process. The entire technology that all these asteroid miners are using is the optical mining technology. And behind this, the most attraction, why I felt it is the most attractive, is because it propels through space using omnivore thruster. Okay? And this thruster uses fuel means water and sunlight. This is fuel. And that is what makes it entirely different from all other companies like Planetary Resources, Deep Space, Kepler Science. It just uses sunlight. Okay, sunlight use either water high pressure release water vapor high pressure release technology Trans-Astron miners use. The previous one was Mini-B, this one is Honey-B. Names are cool. It can basically collect more, more regolith, asteroid regolith, collect size Honey-B as well as the Queen Bee. We know that how these names are coming up for idea. So Queen Bee can collect up to 40 meter, 50 meter size asteroids. Trans-Astron Queen Bee asteroid miner using, and there is an optical omnivore thruster, and they use the optical mining. And you can see how it basically collects it. So you can see a large back-shaped structure. The Planetary Resources there, it has a big back-shaped structure into which this asteroid will go, and then it will do the optical mining. So this optical mining, Planetary Resources, our patentship. So what they do is that Trans-Astron, patentship, and omnivore thrusters in the patentship, Trans-Astron. The thing is, these companies will join together. Whichever side is the best. Successful club missions like International Space Station. Possible. It's not just one single company going there doing mining the asteroid. Okay, the three musketeers. Okay, coming into the last part of this presentation, you can see here just this was from Amazon, Elon Musk from SpaceX, and Richard Branson from Virgin Galactic. ഇവരെ മൂന്നുപേരെ ഞാൻ എടുത്ത് കാണിക്കാനുള്ള മെയിൻ റീസൺ ഇവരാണ് ഇപ്പോഴത്തെ ഒരു ലൈക് സ്പേസ് സയൻസിലെ സൂപ്പർ സ്റ്റാർസിന് നമുക്ക്. സോ Amazon, don't think like Amazon, നമ്മൾ കേട്ടിട്ടുള്ള Amazon ഇതല്ലല്ലോ ചെയ്തുകൊണ്ടിരിക്കുന്നത് എന്ന് വിചാരിക്കട്ടെ. So they have their own rockets. Blue Origin is the rocket of Amazon, and VSS Unity Spaceship is a beautiful design of Virgin Galactic, and it's for space tourism. None other than space tourism. Space tourism often say in the first time. Starship, SpaceX, the planetary traveling in a easily under the Elon Musk brand new rocket. Okay. So if you are super duper rich, then you can basically go out there and visit the space. And let me tell you, they both, I mean, Blue Origin as well as Virgin Galactic have opened a free, tickets for going to space, and you can go into their websites, and it's like a lot system, like a lottery. You can just register it, and if possible, ഭാഗ്യം ഉണ്ടെങ്കിൽ ഈ കേൾക്കുന്ന ആരെങ്കിലും ഒരാൾക്ക് അവിടെ പോയി സ്പേസിൽ പോയി വിസിറ്റ് ചെയ്യാനായിട്ടുള്ള ഒരു ചാൻസ് കിട്ടും. The first person from India is none other than Santosh George Pulangar. Virgin Galactic in the spaceship maybe within 2 years. Fine. And how can we become a space scientist? This is the question that so many students used to ask. Like, information. Summarize it and include it. The number one thing is that you need a PhD to become an astronomer. Okay, and PhD in the if you support that because it's not so difficult thing. It's not the most difficult thing also. It's possible, like if you really wish to. Okay, so the students who complete after 10th standard and 12th standard, they can go to the mainstream science subjects. They can take the mainstream science subjects. They can, after that, they can go for undergraduate courses in astronomy and post-graduation courses, and then they can take PhDs. And there are many colleges offering bachelor's in engineering, bachelor in science courses, especially the highlight India IIST, IIS, ISA, IISC, IITs, NITs, government colleges, and also private colleges like with the engineering college. ഏറ്റവും മനോഹരമായിട്ടുള്ള engineering courses are provided. You should understand that. So you can go to you can become an astronomer even by taking an engineering degree. This is the point. It's not like you just take BSc and MSc and then only you can become an astronomer, not like that. You can even become an engineer and then you can divert your field, which is possible. After all, if I am speaking this much physics after taking an engineering degree, so ഇത് ഞാനൊരു വെറും ചെറിയൊരു എക്സാമ്പിൾ, നിങ്ങൾക്ക് അതിന്റെ മുകളിലോ ഏറ്റവും വലിയ നിലയിലോട്ടൊക്കെ എത്താനായിട്ട് തീർച്ചയായിട്ടും സാധിക്കും. So integrated MSc postgraduate PhD programs provides Indian Institute of Science, IIST integrated courses, and you can basically research on that. Got it? Now, basically the last slide. Here you can see some key terms, the difference between different kinds of branches. People think that there is only two things: astronomy, astrophysics. It's not like that. Astronomy I have already defined. You can see astrophysics. Basically, they are all connected. Study of the physics of the universe, and astrochemistry, astrobio, physical cosmology, extragalactic astronomy, galactic astronomy, stellar astronomy. It goes on. The list goes on. So, ഇത്തരം കോഴ്സസ് എല്ലാം ഇന്ത്യയിലുമുണ്ട്, പുറത്തും പോയി നിങ്ങൾക്ക് പഠിക്കാം. Planetary science, etc. So, if you are not interested in just rockets and mining, but you are interested in dark energy, dark matter, time traveling, all these things, അതിനുള്ള ഓപ്ഷൻസ് PhD എടുക്കുമ്പോൾ അതിനനുസരിച്ച് എടുക്കുക എന്നുള്ള കാര്യമാണ്. So, multi-universe or theoretical physics in the like string theory, M theory goes on. So there are a lot of opportunities. Even after becoming an engineer, you can take that, or after 12th grade, you can take BSc, MSc, like that. It can go on. So you might be thinking like, why I didn't include anywhere the word ISRO. Like throughout the entire presentation, I was mentioning regarding all other companies like Kepler, Deep Space, Planetary Resource, and all other things. So ISRO tribute എന്നുള്ള രീതിയിൽ ഞാനൊരു ചെറിയൊരു സ്ലൈഡ് കാണിക്കാം. അതിനു മുമ്പ്, just before that, let me give you some books to read for 10th and 12th ഒക്കെ കഴിഞ്ഞിരിക്കുന്നവർക്ക്, just for easy picking, like എന്താണ് ഇതിനെയൊക്കെ പറ്റിയിട്ട് മനസ്സിലാക്കാനായിട്ട്. ഇതെല്ലാം ഞാൻ വാങ്ങിയ ബുക്സ് ആണ്. ഇതിലെ ഏറ്റവും എനിക്ക് ഫിഷൻ കാറ്റഗറി, those who are looking for fission category can go for the first one. It's just 6 books. 6 books സെറ്റാണ്. ഇവരൊക്കെ ഞാൻ ആ ബുക്സ് എടുത്ത് വെച്ചിട്ടുണ്ട്. ഇതൊന്നും വെറുതെ തള്ളല്ല എന്ന് കാണിക്കാൻ വേണ്ടി എല്ലാ ബുക്സും ഇവിടെ വെച്ചിട്ടുണ്ട്. ആൻഡ് ദ പോയിന്റ് ഈസ് ഫിഷൻ നോൺ ഫിഷൻ കാറ്റഗറിയിൽ if you are interested, ലാസ്റ്റത്തെ 2 books, Carl Sagan's Cosmos and Brian Greene's Fabric of Cosmos, കുറച്ച് ഹൈ ലെവലാണ്, but still if you're so much into physics, you can read up to the Fabric of Cosmos, which actually bends the space and time. And as the last tribute to ISRO, ഒരു ചെറിയൊരു വീഡിയോ കണ്ടിട്ട് നമുക്ക് ഇതൊന്ന് കൺക്ലൂഡ് ചെയ്യാം. So basically, that's it. And thank you. Thank you for listening to this presentation till this time. And if any questions, please, I'll be happy to answer those.
Wow, that was really a wonderful session and interesting too, and a wonderful presentation as well. Thank you, Paulos.
Thank you.
Participants can unmute and ask your doubts directly, or you can use the chat box as well. Before that, please note that there is a feedback form link that has been provided in the chat box. All participants are requested to please fill a feedback form. So if anyone wants to ask any questions, you may. Or there are already 2 questions in the chat box. Shall I read out, please?
Yeah.
Okay, the first question was from Sudha ma'am. Is bolide listed in the disaster management listing?
Bolide events, yes, ma'am. It's like there is a treaty even created in 1970s, including these dangers that can come. And we have listed into the danger, like an international catastrophe listed even included bolide events. Answer is yes.
Okay. The second question that came in the chat box was, why is the red bar, in brackets, the asteroids that hit without warning, larger in 2019 and smaller in 2013, even though technology has progressed a lot and it's easier to predict if the asteroid will hit now than that time?
Yeah, what I understood from the question is that, why is that, but just a second, let me just go through that a second. Larger in 2019 and smaller in 2013, even though technology has progressed a lot. Yeah. The thing is, as I said, these asteroids means we are not categorizing all of the same size. These are coming of different shaped and different sized objects are coming onto the surface of the Earth. Okay, so number one, most of them are carbonaceous, means which are very, very dark. It's literally difficult to spot out an asteroid using our extreme best telescopes. നമുക്കുള്ള ഏറ്റവും നല്ല ടെലിസ്കോപ്പുകൾ ഉപയോഗിച്ചിട്ട് പോലും നമുക്ക് ഈ ആസ്ട്രോയിഡ്സിനെ ട്രാക്ക് ചെയ്യാൻ ട്രേസ് ചെയ്യാൻ വളരെ ബുദ്ധിമുട്ടാണ്. Even with the Hubble Space or James Webb going to be launched, it's very difficult. So that's why the red bar is always in the high. Yeah.
Where questions?
Okay.
No more questions.
Ma'am, registration form il vanna korchu questions undu. Appo adum kuda njan speed.
Okay, yeah.
Just വായിക്കാം.
Okay.
ചിലത് already slides ൽ actually അതിന്റെ answers വന്നിട്ടുണ്ട്. അപ്പോൾ ഞാൻ slides. Hello.
Yeah. Can hear you.
Okay, slides. Okay. Slides ൽ already വന്ന കുറച്ച് cover ചെയ്ത portions എനിക്ക് തോന്നി. അപ്പോൾ ആ questions ഞാൻ വായിക്കുന്നില്ല. അല്ലാതെ കാണുന്നത് വായിക്കാം. What is the largest asteroid in the solar system?
Yeah, it's the Ceres. Ceres ആണ് ഒരു 900 kilometer sized ആയിട്ടുള്ള asteroid നമ്മൾ which we have found in the asteroid belt. Asteroid belt എന്ന് പറയുമ്പോൾ there is Kuiper belt also and there is Oort cloud also, which is basically the shell of the solar system. അതിൽ asteroid belt ൽ നമ്മൾ കണ്ടുപിടിച്ചിട്ടുള്ള ഏറ്റവും largest asteroid Ceres ആണ്. Kuiper belt, we don't have an idea. We haven't tracked all the asteroids, and beyond that, even we believe that there is a planet 9. അങ്ങനെ ഒരു planet 9 ഉണ്ടെന്ന് പോലും നമ്മൾ കരുതുന്നു, but we have the mathematical equations for that and the possibility where it can find എന്നെല്ലാം നമുക്ക് അറിയാം, but we haven't got evidence. So evidence is the most important thing. Without evidence, there is no point in saying that these planets are there, these asteroids are there. So according to the evidence, according to the information that we have got, Ceres is the largest in the asteroid belt.
Okay, the next one. Why are asteroids called as asteroids?
Why are asteroids called as asteroids? Aster basically a Greek word. It means star. So asteroid എന്ന് പറയുമ്പോൾ star like എന്നാണ്, star like objects. And that's how that name came. Greek words are പൊതുവെ നമ്മൾ നെയിമിങ്ങിന് കൊടുക്കുന്നത്. Greek gods, Greek goddess, ഇവരുടെ എല്ലാം പേരുകളാണ് നമ്മൾ ബേസിക്കലി കൊടുക്കുന്നത്.
Okay. How big is the smallest asteroid?
How big is the smallest asteroid? It can be small as a tiny speck. The thing is how you classify the asteroid. The classification of asteroid, it's വേറെ ഏതെങ്കിലും ഒരു പ്ലാനറ്റിന്റെ ഡെബ്രിസ് ആയി കഴിഞ്ഞാൽ തന്നെ അതിനെ ആസ്ട്രോയിഡ് കാറ്റഗറിയിൽ നമ്മൾ ഇൻക്ലൂഡ് ചെയ്യുന്ന സ്ഥിതിക്ക് സ്മോളസ്റ്റ് ആസ്ട്രോയിഡിന് ഒരു പേരോ അതിനൊരു സൈസോ നമുക്ക് പറയാൻ പറ്റില്ല. ലാർജസ്റ്റ് ആസ്ട്രോയിഡ് മാത്രമാണ് നമ്മൾ ഡിറ്റക്ട് ചെയ്തതിൽ നമുക്ക് വി ക്യാൻ സേ ദാറ്റ്. So Ceres is there on the larger side. The smaller side, it can be any asteroid, and literally every single day, nearly tons of asteroids, tons of meteors have been showered on the Earth. So anything you can categorize into that list.
Okay, so next one is based on that. What does a meteorite look like falling?
Meteorite look like falling means it's like a fireball, as I have already mentioned. It's like a fireball, but its colors will change depending upon the chemical composition. So ഓരോ കളറിനും അതിനനുസരിച്ചുള്ള കെമിക്കൽ കോമ്പസിഷൻ നമുക്ക് ഒരു ലിസ്റ്റ് ഔട്ട് ചെയ്തിട്ടുണ്ട്. അതിനനുസരിച്ചിട്ടാണ് ഇത് നമ്മൾ കാറ്റഗറൈസ് ചെയ്തിട്ടുള്ളത്. ബട്ട് ബേസിക്കലി ഇറ്റ് ലുക്സ് ലൈക്ക് എ ഫയർബോൾ ആൻഡ് ദർ ഈസ് നോർമൽ ഇമ്പാക്ട് ആൻഡ് ആൻ ഇമ്പാക്ട് ത്രൂ ആൻ ആംഗിൾ. അപ്പോൾ ഒരു ഇമ്പാക്ട് ത്രൂ ആംഗിൾ ആണെങ്കിൽ വി ആർ ഓൺ എ സേഫർ സൈഡ്. സോ 2013 ഉണ്ടായ റഷ്യയിലുണ്ടായ ആസ്ട്രോയിഡ് ഇമ്പാക്റ്റില്, it's not the asteroid impact that made the major disaster. The problem what it made is that the shock waves after that impact. So people they all came near to the window side, and they were looking that stream of fire going, and they were very happy. They were taking photos and all those things. But impact കഴിഞ്ഞതിന് ശേഷം പോകുന്ന shock waves are കുറേ damage ഉണ്ടാക്കിയത്. Basically broken the glass, so many were got injured. Nearly 1,600 are reported injuries.
Okay. What happens if an asteroid hits the ocean?
It's the same effect. That the first and foremost thing is that we can expect large tsunamis, large tidal waves up to 100-meter sized tsunamis are നമ്മൾ ഫസ്റ്റ് ആദ്യം തന്നെ എക്സ്പെക്ട് ചെയ്യും. ബട്ട് മോർ ദാൻ ദാറ്റ് ഗ്രൗണ്ടിൽ ഹിറ്റ് ചെയ്യുമ്പോൾ ഉണ്ടാകുന്ന ഒരു ഡസ്റ്റ് മുകളിലോട്ട് വരുന്നത് പോലെ തന്നെ വെള്ളത്തിൽ വന്ന് ഹിറ്റ് ചെയ്യുമ്പോൾ there will be large waves coming out. It can even create earthquakes and അപ്പോൾ it depends upon the size of the asteroid also. As I already said, different sized asteroids different രീതിയിലാണ് momentum earthലോട്ട് അത് ട്രാൻസ്ഫർ ചെയ്യുന്നത്. So depending upon that only we can say, but still if it is of 100 meters and more than that, it can literally create tsunamis.
Okay, and the last question from the registration form. What is the use of meteorite stone?
Meteorite stone, yeah, it's a very important question. Like, there are many people that who claim that they got meteorite, and it's our duty to give that to the government. Government in another കൊടുക്കണ്ടേ, കാരണം it will be enriched with lot of rare earth metals. Rare earth metals കൊണ്ട് വളരെ സമ്പുഷ്ടമായ meteorites ആയിരിക്കും. അത് നമുക്ക് പ്രത്യേകിച്ച് യൂസ് ഒന്നുമില്ല, നമ്മുടെ വീട്ടിൽ കൊണ്ടുപോയി ഷെൽഫിൽ വെക്കാൻ എന്നല്ലാതെ അതുകൊണ്ട് പ്രത്യേകിച്ച് യൂസ് ചെയ്തില്ലെങ്കിൽ we should hand it over. And they can make use of it, because it's very difficult to mine very small amount of platinum from the surface of the earth. But these meteorites might contain these platinum, and we can reduce the pollution. That's a key point. So ഒരു ചെറിയ meteorite piece നമുക്ക് കിട്ടുമ്പോൾ നമ്മൾ അതിലെ attraction നോക്കി consider ചെയ്യാതെ we have to give priority to the rare earth metals that inside it, and we should hand it over. And because it might contain even radioactive metals, and that can actually cause damage. So നമ്മൾ വീട്ടിൽ ഒരു റേഡിയോആക്റ്റീവ് മെറ്റീരിയൽ നമ്മൾ വെച്ച് കഴിഞ്ഞാൽ the radiations that can come out from that, like including beta gamma radiations, that can even it can take even cancer പോലെയുള്ള മാരകമായ രോഗങ്ങൾ പോലും വരാൻ അത് മാത്രം കാരണമാണ്. So it's better to hand it over.
Okay, there are few more questions that came in the chat box. What happens if an asteroid hits the moon?
Asteroid hits are being continuously happening. Asteroid hits continuous ആയിട്ട് വന്നുകൊണ്ടിരിക്കുകയാണ് moon's surface, because there is no atmosphere. There is no atmosphere to completely stop the asteroid forming on the surface of the moon. So if you go to moon and make a base camp, the first thing that you should be careful is that these asteroid hits. Asteroid hits വളരെ കുറവുള്ള സ്ഥലം എന്ന് പറയാൻ പ്രത്യേകിച്ചില്ല. You can see large craters on the surface of the moon. But still, ഉള്ളതിൽ തന്നെ ഒരു നമ്മൾ ഏറ്റവും കുറവ് ഇമ്പാക്റ്റ് ഉള്ള റീജിയൻ കണ്ടെത്തി വേണം ലൂണാർ ബേസ് ക്യാമ്പ്സ് ഒക്കെ വെക്കാൻ തന്നെ. കാരണം ഈവൻ ദാൻ base camps വെക്കുമ്പോൾ പോലും we have to plan for underground base camps. Overhead base camps ആണെങ്കിൽ asteroid impact and more than that radiations can harm our body.
Okay, the next question is there any possible that there could be an asteroid larger than Earth?
Larger than Earth, definitely possible. The thing is that we haven't found out something like that. 6,400 kilometer അല്ലെങ്കിൽ 12,800 kilometer sized diameter on Earth. We don't have much idea about what is out there beyond the solar system. We are a tiny speck in the entire Milky Way galaxy, right? So there are huge and extremely huge planets. The Earth is just like a tiny pebble. About large planets in their remains. അത് സോളാർ സിസ്റ്റത്തിലോട്ട് റീഡയറക്ട് ചെയ്ത് വരുന്ന ഒരു ദിവസം ഉണ്ടെങ്കിൽ maybe we'll find one, but not now.
Okay, the next question is, what happens to a person lost in space?
What happens to a person lost in space? Yes. Till now.
That's a horror question, Paulos. That's a horror question. That's a horror question. It will not happen, okay?
That's the answer. It will not happen. നമ്മൾ അങ്ങനെ സ്പേസിൽ വെറുതെ പോകുന്ന രീതിയിൽ ഒരിക്കലും നമ്മൾ പ്ലാൻ ചെയ്തിട്ടില്ലെങ്കിൽ പോലും it has been like ഒരു minor chance ഉള്ള പോസിബിലിറ്റി മുമ്പ് ഉണ്ടായിട്ടുണ്ട്. Like once an astronaut was after the Russian astronaut പുറത്തുള്ള വർക്ക്സ് എല്ലാം കഴിഞ്ഞ് ഇന്റർനാഷണൽ സ്പേസ് സ്റ്റേഷനിലോട്ട് തിരിച്ച് കയറുന്ന സമയത്ത് ഒരു ടൈനി ഒരു ആളുമായി കണക്ട് ചെയ്തിരുന്ന ബെൽറ്റ് ആൾ കയറുന്നതിന് മുമ്പ് തന്നെ ആൾ ഡിസ്കണക്ട് ചെയ്യും. ബട്ട് ദ തിങ് ഈസ്, ഈവൻ ദോ ഇറ്റ് ഹാപ്പൻസ്, യു ആർ നോട്ട് ഗോയിങ് ടു സ്പേസ് ജസ്റ്റ് ലൈക്ക് ദാറ്റ് ബിക്കോസ് യു ആർ gravitationally tied up with the International Space Station. So even though there is no belt, connected with your body, you are gravitationally attracted with the International Space Station, and you are not going to go like that until and unless some deep space missions are. അപ്പോൾ അങ്ങനെ ഒരു പ്രോബിലിറ്റി വളരെ വളരെ കുറവാണ്. And some kind of debris is hitting the International Space Station, and that damaging the space station as well as the disconnecting the belt, then there can be a chance. അതിനുള്ള പ്രോബിലിറ്റി വളരെ കുറവായതുകൊണ്ട് നമുക്ക് അതുണ്ടാവില്ല എന്ന് വിചാരിക്കും.
Okay, the next question from the chat box. One second. It is said that Jupiter saves Earth from asteroids, but how?
ഒന്ന് റിപ്പീറ്റ് ചെയ്യാമോ?
It is said that Jupiter saves from asteroids, but how?
First part clear അല്ല.
Jupiter saves Earth from
It is said that
Jupiter എന്ന് കേട്ടു.
Jupiter saves.
Yeah. Okay.
Save
Jupiter
from
saves.
asteroids, yeah.
Got it. Jupiter and save. Yeah. Answer is yes. Jupiter is a failed sun. Jupiter is a failed sun. നമ്മൾ ആരും അറിയാത്തൊരു കാര്യമാണ്. നമ്മൾ planet എന്ന് നമ്മൾ പറയുമ്പോൾ what the first thing you should understand is that the composition of Jupiter is nothing but hydrogen and helium. And സണ്ണിലുള്ള അതേ composition ആണ് ജൂപ്പിറ്ററിലും, but it couldn't self-ignite. So basically it's a failed sun. It doesn't have a core also. ഇതുവരെയുള്ള ഇൻഫർമേഷൻ അനുസരിച്ച് ആ പ്ലാനറ്റിന് ഒരു പ്രോപ്പർ കോർ കണ്ടെത്താൻ സാധിച്ചു. It's a gas giant filled with hydrogen and helium and unable to ignite itself. Because of its size, nearly 1,500 Earths can fit inside a Jupiter. And the thing is that it has a huge gravitational pull. So this gravitational pull basically saved so many asteroid hits compared to the before falling into the Earth. So അതിന്റെ gravitational orbit ഈ മാസിനെയും ജൂപ്പിറ്ററിനും ഇടയിൽ ഈ complete asteroid belt വരുന്നതിന്റെ core reason അതാണ്. Jupiter is a massive planet. അപ്പോൾ ഈ കുറെ റീസൺസ് കൊണ്ട് തന്നെയാണ് നമ്മൾ സേഫ് ആയിട്ട് ഇവിടെ ജീവിക്കുന്നത്. There is no doubt in that. So whenever we say thanks to many people, you have to say thanks to the radiation before ozone does. You have to also say thanks to Jupiter. Otherwise, we could have expected a lot of asteroid impacts.
Okay, and explain, do asteroids affect International Space Station?
Do asteroids
affect International Space Station?
Asteroids International Space Station. I don't know whether you have read a news 2 months before. I think it's in August, not 2 months before. In August only, there was a news that International Space Station, the orbit, NASA has launched a spacecraft from here, and it was in the docking process. And while it was docking, this forgot to stop the thrusters. Okay, the rocket in the thrusters is stopped and so the rocket was literally dragging the International Space Station for a few kilometers. It's a very, very dangerous situation. So the same thing you can expect if an asteroid is flying by. Okay, if an asteroid is in a International Space Station, the gravitational pull can basically change the orbit of the International Space Station. The thing is, so far, we consider asteroids okay, even the near Earth asteroids list these asteroids are so far away. So this is space astronomical units calculate asteroid paper you should actually understand at what distance it has actually traveled. 6 lakh kilometers near Earth asteroid. Understand, the moon is 3,84,000 kilometers. And even if an asteroid is flying past 6 lakh kilometers, again it will be treated as a near Earth asteroid. But the answer for the question is like, if the asteroid is flying past by, it's just not affecting the International Space Station. Anything around it will be affected due to the gravitational pull. But is space station thrusters under, it can bring it back to the same orbit. Adana in August ഇത് സംഭവിച്ചപ്പോൾ, അതായത് ഈ റോക്കറ്റ് ഒന്ന് അതിന്റെ പൊസിഷൻ ഓർബിറ്റിൽ നിന്ന് മാറ്റിയപ്പോൾ ഒരു ബിഗ് ഡേഞ്ചർ എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ 7 astronauts are there flying in an empty space. Understand, it can completely crash down to the Pacific Ocean or Indian Ocean. അപ്പോൾ അതിനുള്ള പോസിബിലിറ്റി വളരെ കൂടുതലാണ്, but they have their own mechanisms to bring it back to the orbit.
How much does a space station cost?
Space station
how much?
Space station cost it's literally we can add millions to it. This is what happened. So one particular number and the countries in contribution International Space Station, and we are going to shut it down. I don't think like that we are going to use it that forever. The International Space Station shut down. So before that, some experiments will be conducted, shut down, and then we haven't planned what to do after that. And NASA is planning for a new space station, because even the capability of the space station and capability of the maximum International Space Station it can run maybe more for 10 more years. Shut down and we'll build a new one. So it's literally millions, and a large football court to consider International Space Station. So huge International Space Station some add-ons. So it's literally millions of dollars.
Okay. So how long, in your opinion, will it take for all this mining to become a reality?
Into a reality. So the first thing is that we have to at least go there and collect samples that we have already done. So that part is finished. The samples collect an item, Hayabusa mission, Rosetta mission, missions already possible. Now, within the next decade, it's all a race. Whoever reaching the asteroid and mining it will be the first trillionaire. Okay, so ഇതിനു വേണ്ടി companies ready ആകുന്നുണ്ടോ ഇല്ലയോ എന്നുള്ളതാണ് the only question. So they should get fund. Without getting fund, there is no point in going to that. So fund ആണ് ഏറ്റവും വലിയ problem. And NASA is deeply helping many companies like Deep Space and Planetary Resources. അങ്ങനെയാണെങ്കിൽ maybe within 15 years, we will do one more task. That is, we will take small samples, and then we will bring to low Earth orbit, and then we start mining. And it might take some 30 to 40 years to take large lumps of asteroid and do the mining process.
Okay, due to the shortage of time, we'll just take one last question. There are people who says that there are multiple universe. What do you think on multiple universe?
Multiple universe. What's my opinion about multiple universe? Is that the question? I think that's the question. Okay. The answer for that, multiple universe theory. Okay. Multiple universe theory in Varindo. You should understand number one is that our universe has came out from Big Bang. Big Bang means it's not a bang, it's a big inflation. So our universe is expanding. The space is expanding faster than light. So don't think that nothing crosses the speed of light. It's literally expanding faster than the speed of light. And that's why when you go out and look at the sky, you see a lot of stars, and behind it, it's a dark background. The question is, what is beyond that, right? So നമ്മുടെ universe, fine, we are very happy, we are living happily, everything is safe and sound. Our universe is there, fine. Now there might be another universe which came out from another Big Bang, or from the same point from which our universe has came out, and you can call it as another second universe. And the physics in that universe might be entirely different. Maybe you drop an object, it might go up instead of going down. And in some other universe, the entire things that work will be in the reverse time order. Okay, so you can literally calculate countless number of universes, which is what we call as the infinite universe theory, the M theory. So the M theory pragaram, you can and the string theory, the 10-dimensional string theory and 11-dimensional M theory. According to these theories, you can predict up to infinite universes. And number one thing is that in one universe we are interacting, we are conducting a webinar. Maybe in some other universe, maybe because some fluctuations, this webinar might not be proceeding this time. And in some other universe, I might not be able to even start this webinar, but we are basically living in a probability world. So according to the probability, this is happening in one particular universe, and even universes can even merge together. Multiple universes can merge together. We haven't got the evidence. Like gravitational waves, we are tracking those waves, but if in case we find one, that's the only way that we can conclude that multiple universes do exist. There is no other way till now. So we are waiting for those waves from large gravitational observatories.
Okay, thank you. And with that, we come to the end of the wonderful question answer session as well. To the participants, please fill the feedback form that has been given in the chat box. Now, I invite Dr. Mary P. Verghese, Head of the Department, Electrical and Electronics Engineering Department, to propose a formal vote of thanks.
Thank you, Akhila. Good evening, one and all. Am I audible?
Yes,
Yes, ma'am.
Am I audible?
Yes,
okay, fine. Yeah, I am here to deliver a formal vote of thanks to all those who have attended here, or for all those who have gathered here. First and foremost, I would like to extend heartfelt thanks to our resource person, Mr. Paulus Thomas, for readiness to share his knowledge with us in spite of his busy schedule. His words have thrown light to the vast area of celestial bodies in this attractive manner. Mr. Paulus was my student. I'm really happy to hear his talk on this Teachers' Day. On behalf of the organizing committee, I extend my best gratitude to you. As you told, let's hope safe from asteroid hit in near future. A big thanks to you, Mr. Paulus, for your really informative talk. Next, I would like to extend my wholehearted thanks to our Executive Director, Mr. Suresh Lal, Administrative Director, Mr. P.N. Unirajan, and our Principal, Dr. Saji CB, for supporting us to organize this talk as a part of VIBE activity. I extend my heartfelt thanks to Dr. Sudha Balagopalan, Dean Academics, for the valuable support she has offered. Success of any program definitely lies in the involvement of the participants. Sincere gratitude to all the internal as well as external participants. I extend my heartfelt thanks to all the VIBE committee members, IT support team, and all Vidya family members for making this program a grand success. Thank you all once again. Night.
Thanks, ma'am.
Thank you, ma'am. So with a closing note, I would like to wind up. Space is amazing. The sheer vastness of it, along with the trillions upon trillions of objects in the many billion galaxies of the universe, is almost incomprehensible to the human brain. Thank you all for joining this wonderful session. Thank you. Stay safe.
Thank you. Bye. Bye-bye.
Thank you, Paulus. It was
Thank you,
great.
ma'am.
Okay. We are
Thank you,
we're very
Paulus.
proud of
Thank you,
you.
Paulus.
It's nice to grow a person like you. Okay.
Okay, ma'am. Thank you, ma'am. We'll keep in touch, ma'am.
Yeah. So let's hope that. Okay. Where are you right now?
I'm right now in Thrissur, ma'am.
Thrissur itself. Okay.
Yeah.
So it applies to everyone. Stay safe,
Yeah.
etc. Okay. I think you create a lot of interest as also curiosity, which is very important, which sometimes we cannot create. Okay. Your body language is very good.
Thank you.
Thank you then again. Bye-bye.
Bye-bye.
Let's hope we'll have another session. Okay.
Sure, ma'am. Sure.
Sometime later on. Okay. Bye-bye.
Thank you, Paulus.
Thank you, sir. Thanks a lot.